In this example, we're going to be evaluating a function from a formula. And this happens to be a linear function. All right, so we have f of x equals 3x plus 1. So this is a linear function. It's in the form y equals mx plus b. And again, remember that function notation just says f of x equals y. So when I input x, I'm going to get an output of y. And so this first example says, well, what is f of negative 2? So the negative 2 is inside the parentheses, so it means I want to input negative 2 for x. And all I'm going to do is to substitute that into my formula. So here I'm saying let x equals negative 2. Everywhere there was an x, I'm going to put a negative 2, and then I'm going to evaluate it. So I want to find the value of y when x is equal to negative 2. Now, there is a built-in calculator in Lumen, or you can use this Desmos calculator. This is exactly what is put into Lumen, is the Desmos calculator. So some of these questions you're going to be asked to upload a screenshot of your calculations. So I recommend that you become familiar with the Desmos calculator within Lumen. So I would just do 3 times negative 2 plus 1, and that gives me negative 5. And that's what I have there. And if I wanted to do f of negative 1, I would just say 3 times negative 1 plus 1 is equal to negative 2, and so forth. And so that's how I'm going to evaluate this function. Everywhere I change the input, everywhere there's an x, I'm going to put a negative 1, and I'm going to evaluate it. F of 0 just means substitute in 0 for x, and I get a y value of 1. F of 1 means substitute 1 in for x, or input x equal 1, and then I get an output y equals 4. And the last one, f of 2, just means let x equals 2. Everywhere there's an x, I'm going to input 2 and find the value of y. And what I want to show you here is that we can also write this as an input-output table. So my inputs are the x values, and the outputs are the y values. And you can see here, when I input negative 2, I get an output of 5. When I input negative 1, I get an output of negative 2, and so forth. So I can create an input-output table when I evaluate a function as well. And then we can also look at it graphically. I have it graphed over here as well. We can see that this is a linear function. It passes the vertical line test, right? If I drew a vertical line and I go from left to right, it's never going to go through more than one point. So this is in fact a function, and it's a linear function. And I can look here as well, and I can write each of these ordered pairs to graph it. So when x equals negative 2, y equals negative 5. So when here's my x values, here's my y values, I'm going to go over to negative 2, and then I'm going to go down to where I hit the graph right here, negative 2, negative 5. When I input negative 1, my output's negative 2. So I'm going to come all the way over to negative 1, and I'm going to go down here. This point here then is negative 1, negative 2. Take this last point, 2, 7. I input 2. My inputs are here. I'm going to go over to 2, and then I'm going to travel up to where I hit the graph, and that would be at 7. Y equals 7. So when I input 2, I output 7. 2, 7. All of these I can write as ordered pairs and also graph them. They're all related. So we're going to dive in next unit into domain and range, but let's just talk. So our domain are our inputs. Are there any inputs that we cannot put into this function here? Well, no, this keeps going. As x gets bigger and bigger, y is going to keep getting bigger and bigger. The graph keeps going. As x gets smaller and smaller, y gets smaller and smaller. So there are no exclusions from the domain or the input. I can put really big negative numbers, I can put 0, I can put big numbers. So our domain is all real numbers, negative infinity to positive infinity. And when I look here, are there any outputs that would have to be excluded? Well, no, my outputs keep getting bigger and bigger. These are my outputs, keep getting bigger and bigger on the right. And on the left-hand side, they keep getting smaller and smaller. So my range would be negative infinity to positive infinity as well.